we used to teach this class both fall and winter. And in the winter, we actually had one extra week. I don't quite know how it works that way. And so I had two topics, security and searching. And I would always teach both topics in the winter, but I never could teach them in the fall because we had like one less lecture. And I was looking at the schedule, and I'm like, why am I even bothering to teach HTML anyways? So I decided that I would throw HTML away because it's sort of like the weakest link. And I would put in the lecture that I really like, which is I put searching back in. And so we'll build a simple search engine, second to last week of class, and then we'll finish up with security. So I've reshuffled the October 28th through November 18th, and it also, if you look, it fits the book, and I also revised the book. So I sent you a URL. The book website's not been updated yet, but in a week or two, I will have a new version of the book on CreateSpace. I will have all the PDFs and everything updated. I want to give you a chance to review the draft of the book so you can find all the typos in it, so I'm not too embarrassed when I put the thing up. So I just wrote the whole thing of a new chapter 13, a new chapter 14, and all chapter 15 on Saturday and Sunday this weekend. So it has a high probability of being flawed because I write fast. My muse drinks a lot of coffee apparently, but that doesn't mean, there are so many opportunities, low-hanging fruit to find typos in chapters 12, 13, 14, and 15. Now, if you don't feel like it, just ignore all that. I'll have the book sort of ready in the next couple of weeks, and you'll see the new one, and it'll still have typos in it. But I figured those of you who are eager beavers, I wanted you to take a quick look at it and help me out. So any questions on the change of the syllabus? I'm really geeked about it because I don't have to choose between two topics that I love so much to talk about that I think are both really important to this class. So, okay, so with that, we are going to cover two things today. One is tuples, and the other is regular expressions. Gesundheit. Tuples are kind of like the last thing that we're going to cover that'll be on the midterm. And so the regular expressions, you can kind of think of something you can sleep through if you want, right? You can be relaxed. I think some of you will like regular expressions, and some of you may like it now, you might like it in the future, but it's something that's kind of an acquired taste. So the second half of today will be about regular expressions. So let me go ahead and record the podcast here. Any questions, any issues, any problems? Okay. Oh, I should probably say, I will hand you guys sample midterm exams and actual midterm exams from previous years. And you can do as many of those as you like and talk to your GSIs about doing them. And what happens is after a while, you'll have done so many variants of this kind of programming assignment we're doing in chapters 8, 9, and 10, that when you go to the midterm exam, you'll be like, oh, that's so close to one thing I did. Because I'm not trying to make the midterm exam be dramatically different than anything you've seen. It's going to read a mailbox. It's going to look through the mailbox. It's going to count some stuff, and it's going to print some stuff out. And there's, like, as you see, infinite variations of that problem that I can produce. But hopefully by the time I've had you do so many of these assignments, you will be in good shape to do the midterm. So, and next week is history, so we use that as time to also study for the midterm. Oops. Okay, so welcome to Chapter 11, Tuples. This lecture and the audio and the video are copyright Creative Commons attribution. So it's hard to write a whole chapter in tuples. You'll notice that the chapter in tuples is kind of short because it can almost be summed up with this single slide. Tuples are like lists, except they got like round parentheses. They behave almost exactly like lists, except they have round parentheses. And what are lists? Well, lists are kind of like a well-ordered set of things that have an order. They start at 0, 1, 2, 3, and so away we go. And so if you look at this code we've got here, and I say X equals parentheses Glenn, Sally, and Joseph, separated by commas, you're like, okay, that's just a list with curved parentheses rather than square things. The index operator, which is still square parentheses, works on this, just like it works on strings, and it works on lists, and now it works on tuples. If there's a sequence of things, we use the square brackets, which we call the index operator, to pull pieces out. We print it out, and we see sort of the constant format, which is the parenthesis followed by a comma-separated numbers or strings or whatever. We can call functions like max and min and sum and stuff on them. And, not surprisingly, we can put them inside of a for loop, where we say for iteration variable in some tuple. And it'll just go through the successive elements of the tuple. The iteration variable will walk its way through that, and it will work. Again, boring, because we already know this. The only subtle difference between tuples and lists, and the only difference really that Python even has these two concepts, are tuples are immutable. So we've already talked about things that are mutable and immutable. Lists are mutable, meaning that you can do item assignment, you can change the sub one thing in a list, but you can't do it in a string, right? So that has to do with, mutability has to do with doing something on the left-hand side of an assignment statement. So if you have a list that's got 3 elements of 987, then that's great. We can change the sub 2 element, which of course is the 3rd element, to 6, and it changes because it's mutable, meaning we can change the middle of a list. We can change any item in a list. If we try to do the same thing in a string, ABC, and try to change the 3rd letter to D, we get a traceback. And it's really saying does not support item assignment, which is the notion of putting an index operator on the left-hand side of an assignment statement. So a tuple looks a lot like a list because it's not like a string. It's got 3 or 4 or 1,000 things in it, but it does not support item assignment item assignment. So a tuple is like a limited list. It's a list with features removed, basically. So things like you can't sort a tuple because you can't change it. We can sort a list, but we can't sort a tuple because the tuple, if x dot sort, that's trying to sort in place, right? You can't append to it. Append doesn't work. Reverse, you can reverse lists, but you can't reverse tuples, okay? And so this is all kind of a corollary to the notion that tuples can't be changed. And if you use the dir option inside of Python, we can take a look at sort of just what Python thinks of these two creatures. So we make a list and we say, oh, what can you do, Mr. List? And you go, well, I can append, I can count, I can extend, I can index, I can insert, I can pop, I can remove, I can reverse, I can sort. Then you go, hey, Mr. Tuple, what can you do? I can count and index. That's all I can do. I don't have much capabilities. I can look things up. I can look for how many things are in there, and I can go search for a thing. But I can't change myself. And so anything that had to do with changing is not there. And if in this moment you're kind of thinking to yourself, why? Well, the reason has to do with efficiency, right? That if, now this is sort of computer sciencey stuff, inside of Python, Python has to be prepared for you as a programmer to change anything. It sort of uses more of its memory to store a list than a tuple. Whereas if it knows that you're not allowed to change something, it can squeeze that down to the tightest possible form and use the least amount of memory, okay? And so it's not something that matters too much to you, really. Because you're like, whatever, memory, I got a gigabyte, a couple of gigabytes. What's a couple of gigabytes among friends? And your programs aren't going to be perceptibly faster or slower, but tuples are there for certain situations where we don't want to create all the overhead of a modifiable structure. Not your problem. You use what you want to use, and Python takes care of the rest. But lists are a little less efficient than tuples. Not a lot, just a little. They take extra storage to make lists be as flexible as they are. Now, we looked at this in the last lecture when we talked about the for loop that would go through the key value pairs in a dictionary. This is something, for those of you who know other programming languages, that's kind of unique to Python. And it is one of my, I love this feature in Python. And that is the ability on a left-hand side of an assignment statement to have 2 variables. It's a simultaneous 2-variable assignment. So the syntax for this is you've got a tuple on the right side and a tuple on the left side. And they've got to match in the number, right? So there's got to be two things on both sides. But if there are two things on both sides, X gets 4 and Y gets Fred, right? So Y is Fred and X is 4. And so this is quite nice because now we're sort of able to assign a whole data structure kind of and explode it at the same time. Any questions on that? Yeah. No, it's not just 2. You could have 4, 3. Absolutely, that's a great question. It's not just 2. I use it a lot for 2, partly because the for loop and the items and the dictionaries uses 2, but that's just because you're getting 2 tuples back. So kind of a tuples, if you go mathy, like we call these things, the reason the word tuple is used is math uses this notion of 2 tuples, 3 tuples, 4 tuples, and 5 tuples. Not that this is a math class, but things that have like 5 thingies on them are called 5 tuples in math. So there can be many things. So this would be a 2 tuple. Any questions? Okay. I don't know what that animation was meant. Oh, I know what that animation was meant to call my attention to. It was a glorious animation. You can eliminate the parentheses on the left-hand side. It's kind of a shorthand for it, and I think it's kind of a pretty shorthand. But when you see A comma B equals 99, 98, you got to remember that's the reason that's kind of a contraction for a tuple. And if there are 2 things coming on the right-hand side, there still need to be 2 things on the left-hand side. And this is the syntax that we do in the for statement, right, that we review from last lecture. We have a dictionary. We've got 2 items, CSEV and Chen Wen, and they got numbers. And then we're going to go through the keys and the values. And D items returns now we can be clear on this, a list of tuples. Now we're starting to talk about data structures. Lists that have kind of complex things inside them. Data structures with data structures inside them. Soon we will start playing with things like JSON, and we'll find that it's data structures all the way down, right? Data structures within data structures within data structures. So we have a list of 2 tuples, and each tuple has 2 things in it. And so this ends up being a tuple assignment. The K goes through the keys, and the V goes through the values. So that's what we were playing with last week. There's just not much in this chapter. I mean, you kind of understand it already. This should be the easy one. So here's something cool. Tuples are comparable. So this is like a data structure that you can compare. You can ask if one string is less than another string, but you can't ask if a dictionary is less than another dictionary, because that just is a nonsensical notion. But tuples, with their clear and precise structure, can be compared. You can say, is the set 0, 1, 2 less than 5, 1, 2? And the comparison just does, as you might expect, almost like alphabetical order, it starts with the first one. And so it really doesn't care because 5 is greater than 0, so this is true. It doesn't really even have to look at these 2 things, the 1 and the 2. You don't have to look at it because the 5. It's like if you're sorting alphabetically and the first letter is a W and the first letter of the other word is like J, then the J comes first. It doesn't matter what the rest of the letters are. So that's the same as with a tuple. Now, if you look and you say, oh, the first is the same, well, I got to check to see if the second one. So it goes as far as it has to go, just like it would do in alphabetical comparison. And these things in tuples, like lists, do not have to be numbers. And so in this case, I've got two tuples with strings in them, Jones Sally and Jones Fred. And we're checking to see if they're less. Well, Jones is the same, and Sally is not less than Fred, so this whole thing is false. And within any of these string calculations, well, yeah, I should have put Sam there. If there was an S and an A, then it would go all the way to the 3rd letter. It would go to the first it would check the tuple pieces in order, and then within that it would check the string in order. And this one, Jones, is greater than Adams, and so we don't even look at the Sally and the Sam. Although it'd be more interesting if we did look at the Sally and the Sam, but we don't. Okay? So tuples are comparable. Because they're, yeah. F. J. Oh, Jones. Oh, the first one. The first one. Okay. Because F is less than S. Yeah. I mean, it's just doing what it's doing is doing within those a string comparison. And so the string Sally is is greater than the string Fred. Nope. No. Oh, that's a good question. No. It is. Let me pop up a terminal. That is a great question. That's a great question, because the question you're asking is it about the length of the strings or the content of the strings? So let me just pop a terminal up and make this real clear. Okay, so I'm going to start with this one. Hopefully I can cut and paste without blowing it up. X is equal to that. Okay, so what it really is doing is it's first asking the question, is Jones less than Jones? Right? And if that were true, then the whole thing above would be true. But since that's false, we got to check the next one. And so we got to ask, is Sally less than Fred? And the answer is Sally is not less than Fred. So that overall thing of this thing is also false. And so it's doing equality, right? So it's not looking at the length of the strings. It is doing string comparisons within there, right? Or comparison of what are those things are. F and S, yes. Correct. Exactly. And in the English language, in the ASCII character set. But yeah, absolutely. Right? And so if we made this be Sam, it would look to the A, and the S and the A would match, and then the M would not match, and LM. M is bigger than L. You'd think I'd know my alphabet by this point in my life. And so that's true. And everything matched up to this character, right? And that's where the fact of what was less than mattered, right? And there are crazy things that we can do, like, so if we remember, like, none is less than 0, right? So I could make a tuple and say none Fred 98.6, and I could ask if that was less than 1,000 Steve. And that'd be true, because none is less than 1,000. It really doesn't care about the rest of it. Right? So it's just doing less than, and it's like, oh, well, let's first look at the first two things, none, and is that less than 1,000? Yes, it is. Why we don't care or no. Maybe it's because none is infinitesimally tiny, and 1,000 is not infinitesimally tiny, but that's what they decided, right? Is false less than 1,000? It is. Is true greater than 0? It is. Oh, that's a good question. Wait. Is true less than 0? No, it is not. Yeah, those are decisions that Python made. And that's because, let me see if I can make this work. X is equal to 2 plus true. Print X. True when forced acts as 1. When coerced, when forced, acts as 1. Now, of course, the jury will disregard, if this has confused you, the jury will disregard this digression. So tuples are comparable in the whole, and it compares the pieces, corresponding pieces, and it keeps on looking if it finds things that match, or if it can resolve the decision early. So because of this, we can sort lists of tuples. You can think of tuples as kind of like a just long string of characters, but they're distinct. And so if I make a dictionary that's A, B, and C, and I put it in, if you remember, dictionaries don't maintain order. And so if I do a d.items and say, give me the key value pairs inside this dictionary, they come out in whatever order the dictionary feels like giving them back to us, and they're not in order. So the list T is A, C, B. But because it's a list, and because tuples are individually comparable, we can tell this list of tuples to sort itself based on the relative magnitude of the tuples. And in this tuple, it's going to look at that thing first and then that thing second in each of the comparisons. And it's going to work its way through this list. Even though I've only got 3, it could be 1,000 or 1,000,000 things in this list. And at the end of the day, this list of tuples will be in order based on the key. So it's kind of like take the output of a dictionary and get it sorted in key order by putting it into a list of tuples and then sorting the list of tuples. So now we're starting to use data structures to sort of solve our problem. Dictionaries don't have a capability of being sorted, but we can pull out the key values, make a list of tuples, and then sort that. Any questions? Yeah. Oh, that's coming up in the next slide. Because it's like Mount Everest, because we're climbing towards the ultimate goal of sorting our dictionary. So we're looking for the most common word. We've been questing for the most common word since the beginning of the class. So there's another way to sort things. There's this called sorted, and you can pass in something and get back. So sort something in place. Sorted is a function that takes a list and gives you back a sorted version of it. And so if I want to write in if I got the dictionary, D, if I want to write in one statement a way to go through the dictionary in sorted order, I can say for KV in sorted, that's a function call of D sub items. D sub items, of course, is this non-sorted list of tuples, but sorted, parenthesis, gives us back a sorted list. It takes an unsorted list as its parameter and gives us back a sorted list. And then I can print through my dictionary in sorted order by key with one statement. The sorted is a built-in function. Yeah?
In the first line there, those parentheses look different. They're not brackets.
This? Those are curly braces, and that's because it's a dictionary, not a list or a tuple, right? The curly brace is what we do for dictionaries. Square brace is for list, and round parentheses is for tuples. So I'm starting with a dictionary. Yeah? Well, it uses square braces to make an empty list, right? The book could be flawed. I mean, I know the author. At times not so. So like that's an empty list right there. That's square braces. Yeah, that's an empty dictionary. Now, I don't know if I could even make an empty tuple. It would be like, oops, wait. No, sorry, that was a different problem. I can make an empty tuple too. Wait a sec, we better ask what that is. Okay, so that's an empty tuple. Oh. Excellent question. Okay, so let me make, okay, so here is, that's an empty dictionary. This is another empty dictionary. Okay. That's a really good, and frankly I can do the Z equals square bracket, A is equal to list parenthesis, and I can see B is equal to this, and C is equal to tuple parenthesis. Okay, right? So now this is the source of your confusion. It seems as though there's parentheses over there on those second, fourth, and sixth, but there are curly braces, square braces, and whatever. And the curly braces and square braces and parentheses determine the type of the thing in the first. And that's because these are constants. That's a constant, that's a constant, that's a constant. Those are like constants, like quote, banana quote is a constant. When I'm saying dict, D-I-C-T, or list parenthesis or tuple parenthesis, that is the form of making an empty list calling its constructor. So those are like functions. So dict, list, and tuple are like functions. And I can even put stuff in those parentheses. And that's why they're always a parenthesis when I'm using the constructor form. Because I can say D is equal to list of banana. And that says construct a list based on the letters banana. If I print C, that's what I get. So those things with the parentheses are like function calls. And the only one that's really confusing is the B equal parenthesis guy that's like a tuple. Because it's not a function call. And we are using parentheses both for function calls and for tuples. And that's kind of an overloaded notion. So that's a good question. So I think the book is probably okay then. And you'll notice that I flip between the two things. I sometimes can use the constructor, D-I-C-T parenthesis. Sometimes I just use curly braces next to each other to make an empty one. But the curly brace, the square brace, and the B equals parenthesis, that's more assigning to a constant rather than calling the constructor. Any other questions? Yeah. So this line right here creates a dictionary with key value pairs. Items is a method within dictionaries that gives us back a list of tuples that are key value pairs. This is the thing that's getting sorted. Yep, the A10, C22, B1 is like sort yourself in place, because lists are mutable. So the fact that lists are mutable is really convenient for us all of a sudden, right? Yeah, so sorted is like a function, and we throw something into it, and something comes back. So this is a function return value like max or min or whatever, which is different than a method within an object. So when we say list.sort, mean sort yourself right there. What we're getting is a copy, a sorted copy back, because sorted is a function. And taking as a parameter a list and giving us back a list. It's not the same list, it's a sorted copy of that list. Yeah, the for loop is just going to kind of pop through those things that's coming back from that function, right? The function, this function call, sorted D items, is returning this list, right? I could have put T right here, but then I didn't want to confuse. I want to show you a real short version of it where you put the sorted right there. That K and V is because the thing that's coming back is a list of tuples, and you got two things for each item in that list. And so you want to go cheat, 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 popping through the list. I mean, all your questions are great, and then it quickly becomes an idiom, right? And you just don't even notice it after a while once you get it. Yeah, it's an idiom. Because you know that this is a list of two tuples, and this is a sorted version of that list of two tuples. And if there's two tuples, I'm iterating through two tuples, I need two variables. I can't, if you do this with just one, it'll yell at you. Say, I'm getting two things back every time I'm going through this structure, and I got only one place to put them. So it'll yell at you if you only do one. Yeah. You're gaining power right now. I can see it. Yeah. Yes. Sort. Yeah. Sort is a method for lists. Sort is something we can tell lists to do to themselves. Sorted is a function that takes a list as a parameter and gives us back a new list as a return value. Now we're talking like object-oriented stuff, right? The preferred way to do this, there's sort of like, in Python, there's kind of like these religions of what is the most Pythonic way to do something. There's this term that's like, you could go to the bar and hang out with Python people, and you could now argue with Python people, is the t.sort, making a list and calling the sort method within list, as we're doing on this slide, t.sort parenthesis, or calling sorted, passing the list in and getting a sorted thing, which is more Pythonic? Like, which is, they're the same. As a programmer, they accomplish the exact same thing. The question is, which is like cooler, more Pythonic? Pythonic meaning it's a good thing, more like the creators of Python would imagine is the right thing. And it turns out that sorted is a recent addition to Python, and it's seen as more Pythonic than making a list and sorting it in place. And I don't want to kind of go into the ugly details about it, but if your lists are really big, they like this notion, right? If you have a billion things in your list or a million things in your list, they think that the sorted thing has potential to be more efficient than the other way. And so I don't want, this isn't a class about efficiency, although toward the end of the semester, we'll start running things that slow your computer down. So maybe efficiency will matter all of a sudden, a little bit. But the reason for this difference is one has the potential to be more efficient. Python people would prefer to use this sorted paradigm where it can, and in exactly this kind of form. Any more questions? This is good stuff because you're starting to understand data structures, and if you understand them, you can make them be powerful for you. Yeah, yeah. Well, so an empty tuple would have a length of 0. If you looked up the sub-0 item, it would blow up because there's nothing in it. And because it can't be changed, like there's no append, you got it. It's like an empty string, like double quote, or single quote. You've made a string. You can't look up anything inside it, and you can't put anything in it because it's immutable. So an empty tuple, there might be a situation where an empty tuple is valuable, but yeah, it's not much value. An empty list is far more valuable because you can append stuff to a list. And it's actually very commonly done where you start with an empty list. But starting with an empty tuple, I don't know. You know, I would prefer to say none instead of an empty tuple. But yeah, you just can't change it because it's not mutable. Any other questions? Okay. Okay. So now we come to the money shot. We have been spending a lot of time to look for the most common word in large amounts of text. We have written a list that can find the largest word because we make a dictionary and we run through the dictionary looking for the largest one and remembering the word that was the largest word. We did that a bunch of times. But we want the top 10. We don't just want the largest one. We've already got code to do that, but we want the top 10. Or, in one of the programming assignments, I want to check the time of day and print out, based on the time of day, what I want my histogram to be sorted by time of day. Actually, that's key, so that's easy. Okay. So what we want to do is, I've given you a way to take a dictionary and sort it by key, but we really want to sort the dictionary by value, because the dictionary is a histogram, right? It's a set of counts, which turns into a histogram. And how do you find the top 10? Or how do you find the top 5? So here's how you do it. You construct a list of tuples, but you flip the order of the key and the value in the tuple. So instead of making just items, I'm going to start here by saying temp equals list, and then I'm going to go through all the items, not in order. And then I'm going to append to my list a tuple, vk, a two-tuple, the value in the key. It's just like items, but I've flipped the value in the key, so that the value is first and the key is second in the tuple. So if you take a look at what comes out of that loop, you've got 10A, 22C, and 1B. But now if you sort that whole list, and it's going to do tuple by tuple comparison, it will sort based on the first thing before it looks at the second thing. So now it is sorting by the value, and I say reverse equals true so that I get my 22 comes out first, the 10 comes out second, and the 1. So I've just taken my dictionary, and by flipping the order of the tuples and then sorting, I get the highest count rather than the lexicographically lowest or highest key. Let's go through this slowly. Right? So I'm starting with a list. I'm going to make a list of tuples. So I make an empty list with the constructor, temp equals list parenthesis. And then I go through the items not sorted, and this is giving me key value pairs. And I've got my K and V as my iteration variables. Right? This inner parenthesis of temp append, that is a tuple. V and K are variables, so whatever the numbers are in V and K, a tuple is created and stuck into the list. So we're using append to make a sort of complex multi-level data structure where the things inside are tuples. Then it's ready for sorting. So I thought this through carefully, and I constructed something to make the next part easy. I made a list where the tuples were in exactly the order that I wanted them in so that sort would achieve my goal. And then I get them sorted. So any questions on this line? This is an important page. Yeah. Yeah, I mean, if you look at this, the documentation for sort, there are various things you can pass into that sort, and all reverse equals true is a very specialized thing. You can't put any old thing in there you want. There's a special parameter to sort called reverse that's either true or false. And I want the sort in reverse order, which means it's descending rather than ascending. So if I don't put that in, the sort is going to be, everything we've done in sort has been alphabetic and ascending order, so A comes first. But I want the biggest one. I want the top 10. And so I want the biggest ones to come first, so I want a descending sort. It would probably be more appropriate to call this ascending and descending rather than reverse, right? So ascending is default, and reverse equals true means descending. But I think it'd be better expressed as ascending and descending. When we get to SQL, that's how they call it, ascending and descending, because it's real direct that way. This is reverse or not to reverse, that is the question. But it's really ascending or descending. Yeah. What is what? Yeah, we've done that before. Items returns the list of tuples that are key value. And we've been using that to iterate through dictionaries all along. It just is key value. Yeah. We've been doing that for a couple of lectures now. That's how you go through dictionaries key value. And so, yeah. So this K and V are going to go through it, but then I'm flipping. Okay. Yeah. Yeah. Yeah, the 1 would come out first, right? Then the 10. So the reverse has nothing to do with which order we look at the tuples. That'd be kind of cool if we could say, hey, look at the tuples backwards. That'd be called backwards equals true. Then we wouldn't have to go through all this trouble. We could make the original thing and say look backwards. And we'll see a way to actually say that. You can't quite say look backwards. Yeah. Correct. Well, I mean, append is a method within lists that says take as parameter, and then temp square bracket says add to the end. I think that works. The constructor format, the constructor style. That's the way we're calling it. It looks a lot like a function, right? Yeah, I think of it as a function that returns something. Yeah, very function-esque. Yeah, it technically turns out to be a method, so that's why I don't want to say it's not a method. But as we're calling it, it looks like how Because when we call methods, we say something dot to get to the method. No, there's not. No. It turns out that when you put the square brackets in, Python under the covers calls list parenthesis. List parenthesis is what's really happening, right? And so, yeah. As a matter of fact, if you call, so if you do something like, let me pop up the terminal program here for a second. If you say something like A is equal to square bracket, Joseph, comma, Sally, you're like, oh, that's pretty convenient. Well, Python's going to transform this into A is equal to list, parenthesis, A dot append, Joseph. It just turns it into that stuff, right? I probably shouldn't. I should probably have done the whole thing. I don't want to confuse you. Okay, so you do this, right? And it in the cover, under the covers, as a convenience to you, it does this. They both achieve the same thing, and one is just kind of a contraction for us as programmers to be more convenient. So don't think of them as somehow profoundly different. What you said when you started talking was, I find the square brackets a more convenient thing, and that's exactly what they are. They're a more convenient thing, but they're the same thing. They're just a more convenient way of doing it. But under the covers, we're making an object that's an empty list, and we're sticking two things into it, and away you go. So that's the constructor process. It's just, you don't have to do this. Python does that for you. Any other questions? Okay. So, we are about ready to do our most awesome counting application so far. But before we do that, I want to show a video from our sponsor. We have been obsessed with counting now for 5 weeks. But there is someone in this world who is far more obsessed with counting than we are. We are inspired by this person's obsession.
Oh, brother, I better get started. Big Bird, I heard the news and I know just what you need.
Requirements, right? He is faced with a problem, a data problem. So we know what Big Bird needs, some Python code.
Counting of gold.
Counting? What's counting?
Counting is wonderful. Counting is marvelous. Counting is the best thing you do. Counting is happiness. Counting is ecstasy. I love to count, don't you? You can count when you're happy. 1, 2, 3, 4. You can count when you're sad.
So like that's a patron saint of SI 502 pretty much, right, is the count. Now, if the count wanted to separately count puppets, adults, and children, what Python data structure should the count use? A dictionary. And if the account wanted to sort those and find out which was the most common thing on Sesame Street of puppets, adults, and children, then we would write this code. Okay. So, we're going to find the top 10 most common words in this little romeo.txt file that you can download from the website. And so now this is the new idiom. Most of this is idioms that we've been doing all along, right? So we open a file. We make an empty dictionary. Call it counts in honor of the Sesame Street character. We have a 4-line in fand, a loop that goes through and iterates through the file and reads each line. Then we split the line. You'll notice I don't have a strip in here, and that's because split just kind of throws that new line away anyways. And if all we're doing is splitting it, we really don't have to throw the new line away separately. Then I have an iteration that goes through each count in the line, through each word in the line. And then I have my counts word equals counts get word 0 plus 1, which is our histogram incrementing / creating idiom that we do all in one line. Right. Then, at that point in the code, we have all of the counts, the histogram of the words, but not in the right order. So then what we do is we follow the next idiom of make a list, and we iterate through the list, and we create backwards tuples inside that list, where the value is the first part of the tuple, and the key is the second part of the tuple. So we just kind of make a list with the value as the first part. We've set ourselves up to sort that list, and then we say sort backwards, or sort descending, which is this line, right? Sort descending. And then we simply iterate through that sorted list. And because I've got it backwards, I've got my two variables in my for loop as val key, because that's the order they are in that list. I constructed them as value key tuples. And I use list slicing to say list bracket colon 10. So that's starting at the beginning up to but not including 10, which since they start at 0 is the first 10 things. So this is the top 10 words. And I print them out in the order that I mentally expect them to be, in the word number order rather than the number word order. I'm going through the list. The list is a number word list because that's what it took to get it sorted. And out come the top 10 most common words. Literally of any text file or file we can find. So it all comes down to sort of like learning these idioms, right? And kind of grokking the idioms, because at the end of the day, I could write this a lot longer, and cognitively you might be able to look at each line and make sense of it more easily. But if you kind of get the idioms, then I can write really dense code that we all can understand. And that's sort of why half the time I'm teaching idioms. Say, oh, yeah, that's this thing right here, this 2-line thing of a for loop and a counts get. Oh, yeah, that's the create / add to a dictionary idiom, right? And then you just see this little 3-line thing here of the list and the appending backwards. It's like, oh, that's the old backwards appending idiom, because he's going to sort it next, right? And, and so at some point you just say, these idioms are the tools you sort of throw at the problem, right? You don't just have to construct them all from scratch once you understand them. And that's why we spend so much time in programming, like grabbing code that we had before, because we're just like stealing the idioms that we wrote up before, and we sort of believe the idioms, and the idioms work, and you don't have to reconstruct them. That's why don't throw away any of your code. Yeah?
Sorting, if you wanted to sort without output, there's like a bunch of things with the same number kind of thing out.
Yeah. Then it'll go ahead.
So, it's giving it to us in reverse alphabetical order.
Well, it's giving the reverse numerical order because the values are numbers.
But like, it's not random, but it gives you like
Correct. So I think the question that you're trying to express is, what if there are ties? How does that work, right? So let me just put that up in terminal and just type what I think you're saying, and you can tell me if I'm wrong. So if I make a list of, let's make a dictionary. D is equal to the, 3, 2, 3, and a 3. Right? So now we just counted some stuff, and there's 3 thes in there, and there's 3 2's in there, and there are 3 a's. Now, the items, I'll just type it in. The items would end up being a list of the, tuples, the 3, 2, oh wait, sorry, I'm flipping, I gotta flip them, 3 comma the, wow, it might be easier to write the code than to type this in. 2 comma 3 comma 2 and 3 comma a. That's the so 3 comma the, 3 comma 2, 3 comma a is the value key list, and now I'm going to say list.sort. And the question you were asking is, since the values are all 3, does it fall down and look at the second thing, putting them in alphabetical order? And the answer is yes. Because Python doesn't care that these are words and counts. It thinks of them as tuples. And when it's looking at tuples and comparing them, and the first things are equal, it falls to the second thing to determine sort of relative magnitude, if one thing is bigger than the other. So if we print list, it will be exactly as you expected. The 3's contribute nothing to the actual order, and the thing falls out as a, the, and 2. So it's not exactly the top 10 words. It is kind of like, hopefully there's no ties, so it is the top 10 words, but if there's ties, you know, it's going to behave just that way.
And like if you had said list.sort, and then said verse equals
Yep.
true, then
Oh, yeah, great. And I can do list.sort verse equals true, because the list is still sitting there. Right? So now the 3's, again, contribute nothing to the ultimate order, so it has to fall back to the second thing in the tuple, and the 2 is the, you know, and away it goes. Because Python is mindless on this. We're making just structures that have meaning to us, but Python's like, I'll sort your stuff for you without thinking.
using in the chapter, I guess it was chapter 9 about how they move in alphabetical order. Sort does that kind of automatically. You don't have to like make
Yeah.
something else up.
Right, because if you're sorting just one thing, a list of strings or a list of numbers, you don't have to kind of play with what's the key. Right? If you were thinking, you know, do you want to sort by the first thing or the second thing? Right? Now, and I'm going to guess that some of you are like, there's got to be like an easier and more direct way to do this. There really is. And there is. But for some value of easier. So let me show you the really succinct, really easy way to do this. And the reason I didn't show it to you is I was afraid it would confuse you. But it's actually pretty slick. So on this next slide, if you don't get it, ignore what I'm about to say. But if you do get it, appreciate the awesomeness of it. Now this is a situation where sometimes a few more lines is cognitively more easily understood until you understand the new idiom. So this is taking this idiom and squeezing it down into an even smaller idiom. So now I can do it in 2 lines. I create my dictionary. C is equal to A10, B1, and C22. And then I say print sorted, square bracket, VK for KV in C items, parenthesis, square bracket, round parenthesis. So I'll explain what this is, but if you don't want to understand it, feel free to watch Facebook for a while because I don't want to confuse you. So we've always thought of a for loop as a thing that says do this block of text a bunch of times. This is kind of like an implied for loop. It's almost like treating the for like a function. It's going to belch things out. It's like bloop, bloop, bloop. The K's and the V's are kind of belching out. And this is like belch out a series of K's and V's. And when you're belching them, make a tuple. And then let's take all those tuples that you just belched out and just wrap them in a list. So this is kind of implicit, right? It's sort of flipping it, right? It's an expression of what you want. If I was to use mathematical words, not English, to express this, I would say this is a list of all VK such that KV are the keys and values in a dictionary. Kind of a such that. So if you're a math person and you kind of remember the such that, which is kind of like a vertical bar, it's the VKs such that this is true. Such that V and K are keys and values in the dictionary that I'm looking at. So then I produce this giant list, and the moment I produce it, I just shove it into sorted as a function call. And what do I get back from sorted? I get a sorted version of that list. So I'm done. Okay? And again, if you sat me down in a computer and caught me in a coffee shop and I was in the middle of doing something else, and you told me to write this line of code, it would take me a while to write it. I mean, I understand it perfectly when I look at it, but I mean, I'm a computer scientist for 35 years, and I couldn't disgorge this line of code because I don't write Python often enough. Now, if I wrote Python every day, it would come like that, because it's like an idiom. Yeah. Oh, good question. So I'm going to say something, and then I'm going to have to check it, okay? I'll say what I think is true, and then we can check it. I think you would put right here, reverse equals true. It would, because in effect, that means that there are two parameters to sort it. The first is the list to be sorted, and the rest of them are like telling you how to do the sort. No, reverse equals true would be a parameter to sorted. Now that I said what I think the answer is, we will use Google to find out what the answer really is. Come on, Google, save me. So, Python sorted function parameters. Oh, this is a great wiki, by the way. I think I even have this in the slide. It's like, this is the most, they use the word Pythonic in here, I think. Well, they don't. Oh, okay. This is a really good thing. If you really dig this, it tells you all these cool things, and I go look at this all the time. But that's not what I was coming to look at. I was looking at the sorted. See, thank you. Okay. Yeah. So iterable, that first parameter is the thing it can go through, which is the list that we're passing in. And this CMP and key, they don't have to be, you could say reverse equals, and that way you don't have to make it as the second or third or fourth parameter. So yeah, reverse equals true would come after the bracket, because iterable, that iterable is indeed, this is the first parameter to sorted. And if I put a comma here and then another parameter, I could do it. And you're right, I should do that, because reverse equals true is what we've been doing. Any other questions? Yeah. You mean just kind of did these in different orders?
Or like if you did 10A, 1, 2, 3, 4, and
Yeah.
then for the second time,
Yep.
you
Well,
have different key values.
why do I want to do that, though, right? If you remember, that's a histogram, right? So I'm not going to make, I don't know the counts in advance. I mean, I'm assuming this is kind of a histogram. But yeah, but
Well, like if you were to
finish your,
reverse it with this printed out.
yeah. Python Python doesn't know the meaning of any of this. It just mechanically does what you say, and it does tuple comparisons, looking at the first thing and the second thing. And you can make this thing jump and spin and however you want. It'll do what you say, not necessarily what you mean. It'll do what you say. That's one of the problems, yeah. If I was trying to solve the top 10 problem, yes, I would have to do the reverse equals true. Or I'd have to go look at the end of the list I get back instead of the beginning. So yeah, that's a good point. Reverse, in this little thing, to make it equivalent to the previous slide, reverse equals true would be essential. And I could even get crazier. Here, let me get crazier. I get the sense that I'm not confusing you, so I feel good about that, right? I feel good. If you're confused, don't just ignore what I'm doing. So here we go. So let's go. Okay, so if I say print that, so the first flaw that I made was I need to say reverse equals true. Yep. You guys are traced back and for me. Right? Okay, so now let me sort of blow your mind even more. Now again, this isn't always a good thing, okay? Because when it confuses you, it's a bad thing. But if it doesn't confuse you, it's a good thing. Because you go like, oh, of course, it all fits together. So if it confuses you, pretend I didn't say it. If it doesn't confuse you, because sorted is giving me back a list, I can put a slice on the end of it. So I'm saying the first two of the thing that I get back from sorted. Oh no, the first one, up to but not including one. Sorry, 0 up to but not including 1. So that's the top one. Because I got from sorted is a function that gave me back a list, bam, I put a slice on the end of it. And again, these contractions cognitively distract you sometimes, but then once you really get them, they're cognitive power. They're powerful to you. And when you look at something like that, if I'm a programmer and I send you this, you got to kind of sit down and go like, okay, that first thing's a list, and reverse equals true is a second parameter. Oh, and he's doing a slice at the end. Oh, that's right, it's a list that comes up. I mean, you can kind of parse the idioms if you see them. But I tend to like, if I'm on an exam, I tend to not write the tightest idiom unless I really kind of am a master of the idiom at that point. Then go ahead and use the idiom and see if you can't get your exam question down to one line. Because you probably could if you worked hard enough to get it down to one line. But at some point, you lose the cognitive value. So, okay. So we are now at the end of the stuff that's going to be on the exam. All right? So if you've got this and you're still with us, the exam should be a piece of cake at this point, right? It's just a matter of sort of performing under pressure. It's not like there's some new concept that's going to arrive, like three-dimensional glasses in data or something like that. It's just the things that, tuples and dictionaries and files and splits and strings, that's what the exam is going to be. And so I would say in the next 2 weeks, the thing for you to do is just become like a ninja warrior on this stuff, right? And just like, oh, I know what to do now. I got to slice. I know what to do. I got to sort. Oh, that's right. And I even remember that sort is a method and sorted is a function. And another thing that I tell people to do is go back and do previous assignments and time yourself, right? So you got them. You might have had some fits and starts and bounce your way through, but go back, do the assignments from 7, 8, and 9, and 10, and then give yourself a timer, okay? Because you should understand them because you got a solution. So hide the solution, go from scratch. Can you do an assignment from chapter 7 in 10 minutes? And I bet you can. I bet you can, right? Especially after you've done the assignments in chapter 10. You can go back and do a chapter 7 assignment. If you remember, all we did in chapter 7 was read a file and convert it to uppercase, right? It's like 6 lines. You guys are all ninjas by now. So now in the next 45 minutes, I'm going to teach you a whole new programming language. It's such an awesome programming language, it fits on 1/2 sheet of paper. just take one of these, sort of pass them around so everyone gets one of these little sheets of paper. There'll be a bunch left over. Hey, Megan. Yeah, there'll be a zillion left over. Okay, so like I said, now you're learning something voluntarily, because there is no exam on this, and it won't be on the final either, right? So you can just relax. It won't be on the midterm. It won't be on the final. It won't be required for any other programming assignment. It's just awesomeness, okay? So let me start my other recording for our students who are not here. Okay, so welcome to Chapter 11, Regular Expressions. As always, this material is copyright Creative Commons. So in the earliest of days of computing, everything was about numbers. And then it didn't take very long before it became about symbols, letters, and communications, and whatever. And so the earliest of programming languages, like Fortran, which stood for Formula-Oriented Translation Language, which was very much like mathematics. Then once the world started doing all these symbolic things, there was a whole series of languages that came out aimed at symbolic computations rather than sort of numerical computations. And regular expressions are a computer science concept. You can study them extensively, how to implement regular expressions, et cetera, et cetera, et cetera. For us non-computer scientists, the key is that they are a very powerful and succinct way of expressing what we're looking for. So a lot of what we're doing is looking for needles in haystacks and pulling data out. And so this regular expression language is like a mini programming language just for that purpose, okay? It's like really clever wildcard expressions that are really, really, really clever. So they're very powerful and very cryptic and very dense. So unlike, and I've been talking about this all along, sometimes the cryptic stuff makes the dense stuff is the most sensible, and sometimes the more expanded stuff is the most sensible. And I kind of go back and forth between giving you expanded versions of things and dense versions of things. This is very dense. It's a little language. It has all these marker characters. $sign means something in this language. So we don't have like if. We don't have like reserved words in this language. We have reserved characters. So it's a very character-oriented language. It's very compact. Comes from the 1960s. And so here is a XKCD comic. So whenever I learn a new skill, I concoct an elaborate fantasy scenario that lets me save the day. Oh no, the killer has followed her on vacation. But to find them, we have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. Everybody stand back because I know regular expressions. And then they use Perl, which is the language that sort of famously, regular expressions is essential to Perl. And away we go and save the day in XKCD. I love XKCD because it is legal to put an XKCD comic in a lecture as long as you put the URL in. It's licensed in such a way that as long as you attribute it, you can put it in. So it's not a copyright. Putting Doonesbury is a copyright violation. But XKCD, being a cool, hip, modern person, understands that we will use it. In my Coursera Online Internet History Technology class, one of the study guides that were produced by the students was all of the XKCD cartoons that would apply to each lecture. So there was the XKCD study guide that had IP addresses, and there's a lot of XKCD about the internet. So, so maybe I'll pull that out of my Coursera class and hand that out to us as well, of all the relevant XKCD cartoons. So here is not the entire, but this is what I just handed out to you, the regular expression quick guide. And what it's, again, there are no reserved words, but there are reserved characters. And so what it's saying is the caret, the little up arrow hat thing, matches the beginning of a line. And the dollar sign matches the end of a line. And a dot matches any character. And these are the pieces of programming. We are building things. Star is repeating a thing 0 or more times. Plus means repeat that most recent thing. Square brackets identify a set of characters. So square bracket A-E-I-O-U says I'm going to match lowercase vowels. There you can put inside the square brackets the not. If the first character is up, if the first character is a caret inside of the square brackets, that means not of whatever it is. It's like blah, blah. I'm looking for an X or a Y or a Z not. And so this has got ifs, it's got looping, it's got all kinds of stuff, and it's just a character. It's a language that's encoded in a weird set of characters. And then if we're actually going to parse and extract data, we can do it all at the same time, both finding and extracting data, and we use parentheses to do that. Okay? So probably the best thing is to show you some examples. So it's like a lot of Python where we just import a module. So we import the RE module to get the regular expression library. So this is a series of sort of before and after. On the left, I have the way we would do it without regular expressions, and then on the right, I have the way we would do it with regular expressions. So this is kind of a Rosetta Stone for regular expressions, and the left is the French, of course, assuming we're Western and modern, and the right is the Egyptian, the new thing we're trying to learn. And so, so here we have our idiom of opening a file, reading each line, stripping the white space, and then searching for the word from : somewhere in the line. And if we find it, then we print the line, right? Standard idiom that we've been doing all along. And we do the same thing with regular expression. We import the regular expression library. We open the file, we read through it, we strip it, and we call the regular expression search. Now, for now, we're just doing simple stuff. So regular expression is far more powerful than find, but for now, we're going to use it to do the same thing, just to get used to it. RE search, that says find me the search function within the regular expression library. And the first parameter is the thing we're looking for, and the second parameter is the string to look within. And it's true or false. Did you find it or did you not find it? So these two things are equivalent. So we can use re.search like find. We can also use re.search like starts with. So if we want to find lines that start with from : then again, all of it's the same. On the left side, we're just saying line starts with from. On the right side, we import the regular expression, and we just change re.search, and now we're using our first sort of meta character, our first little programming thing. So when I say caret from : I don't mean a line that has a caret in it. I mean that F has to be the first character, right? So that virtually matches the beginning of the line. So inside this little string is itself a programming language. It's like Men in Black, when the guy opened up the locker and there was a whole world inside the locker, right? So we open up a string and there's a whole programming language inside the string. So the caret is code. The caret is your instructions. It is not saying, give me a caret. Okay? As in C-A-R-E-T rather than C-A-R-O-T. T or R. Oh, spelling. Just Google ruins spelling. Okay. Wildcard characters. So now I have, if you'll notice in our mailbox, there's all these header lines that start with X dash something or other, followed by a colon. And so I can write a regular expression that matches all those strings in 5 short characters. I can say caret, capital X. That says find lines that start with capital X. Dot means any character. Dot means any character. And star means, star goes back to the left and says that thing I just had, as many times as you like. Push out. It's kind of an expander. So then match a colon, right? Then match a colon. So find caret x, start the line with the first character's got to be an x, followed by some number of characters that we don't care about, followed by a colon. So we just wrote a loop, right? This dot star is kind of like a for loop in tiny syntax, tiny baby syntax. And so you see these matches, right? The x matches. The rest of this stuff doesn't really matter. And then the colon matches. And so these lines match. So we're asking, do these lines match the pattern we're applying to it? So you think of it, I'm applying a regular expression to a string, and it's either found it or it didn't find it. And in these lines, it finds it. Now these things are quite powerful. So for example, this match, start with an x, start with a capital X, have any number of characters in a colon, will match the kinds of lines we're expecting, x-civ colon or x-dspam result colon. But if somewhere in the thing it has the line x plane is behind schedule colon 2 weeks, the mindless regular expression will be happy because it says, you have spoken to me and told me when I find a capital X at the beginning of the line, followed by any number of characters, followed by a colon, then that is what your wishes are, O master. And it happily gives you back. So again, like all programs, it doesn't do what you mean for it to do. It does exactly what you tell it to do. And it will always find jokes to play on you, where what you told it to do is not what you intended, and then throw that in your face all the time. So at some point, part of this is getting your code right to say, oh, wait a sec, I'm matching things I didn't want to match. But we can fix that. There's other characters. So I can say, you know what? I don't want this line just to start with x. I want it to start with x dash, because that gets rid of more lines, right? And you know what? I only want non-blank characters. So this \s, capital S, that's in our little programming language. That means a non-blank character, right? So \s is in code non-blank character. Plus is one or more times. So this says, I want a line that starts with x dash, and then has, after that, one or more non-blank characters followed by a colon. So if there's blanks in there, then it's not eligible anymore, right? And so these first two, x-civ colon, is, it starts with x dash, has some non-blank characters and a colon, thumbs up, your happy little regular expression finds that, x-dspam result colon finds that, but x plane behind schedule 2 weeks, it almost found it, but there's no dash, and there's some spaces. So that is not a match. So you can just kind of add these little things and change it. But if you were doing this in Python, you'd be throwing some more if statements in there, and some finds, and some pauses, and some slices, and a couple of splits. But in regular expressions, we like add one character, and it like leaps to what we tell it to do. Any questions? Yeah.
I'm not sure if we're going to talk on this, but so could you for exercise last week where we had to stick the number or you don't?
I'm going there. Yep. Yeah, that actually brings up a really good sort of question. Yeah, brings up a question like, could you use this to do the final exam? The midterm exam. And the answer is, yeah, we don't care, but you don't have to, right? Because some of you are going to get this, and you're like, why did I learn that other crap, right? Like, this is the way I should have done it all along, and why don't you just teach me this from the beginning? And others of you are like, whoa, this is weird. I'm talking to aliens. And that's okay. It's okay. But if you like it, you can use it. And I will do that one again. And you will see that it's more elegant if you get it. It's not more, it's totally confusing if you're just like, whoa, lots of characters. Again, different people see this differently, and that's okay. Okay, so now we're going to talk about pulling data out. I mentioned at the beginning that if in the little string it sees a pair of square brackets, it has, in that is a single character. So that matches one character. And the stuff inside the brackets are the set of characters that match. And you can use dashes. Like you can say A-Z. or capital A dash capital Z, or 0-9. So what this is bracket 0-9 is programming language in regex for a digit. Find me a digit. Then the plus is a modifier that modifies the immediately preceding character. That was one character. Bracket 0-9 is a digit. So now bracket 0-9 plus is one or more digits. So I can call a find-all method and pass it as the first parameter, a regular expression, and the second parameter is a string. And what find-all will do is go through the string as many times as it can and find the things that match your regular expression and give you back a list of the things that match the regular expression. So if I say my two favorite numbers are 19 and 42, and I say, hey, find all the one or more sequences of numbers and separate those out and give them back to me, I will get back a list of 2, 19, and 42.
What about the negative numbers?
I would have to put a minus sign there, I think.
Negative 0.
No. This is a set, right?
Okay.
So I could, so just as an example, I may need to, oh, I don't want my email. I don't want my email. I want a text edit. So just as an example, I could say A-Z, A-Z, 0-9. That's a single character that is a uppercase letter, lowercase letter, or a number. So that's still a single case character. So the question would be, if I want a dash in there, could I do dash 0-9? Because it's going to look at the dashes. See, I got to look at the documentation now. Because in this point, that is not a dash. It is giving me a range. But perhaps if it's the first character, maybe it is a minus sign. I have to read the documentation. Hang on. How do you extract negative integers with a regular expression? I could write like a bunch of code until I figured it out, or I could just hope that Stack Overflow already has it. Let's see if I'm running. So here's Stack. I want to validate a number using regex. The number's got to be a negative 3-digit number to a positive 3-digit number, but it cannot be 0. Oh. Okay. So it's a programming language. I forgot. There's an easy way to do this. That's wrong. This is wrong. I would say minus plus 0 through 9. That would do it. Oh, no. Oh, wait. Oh, you have all my cheat sheets. Crap. Crap. See, my cheat sheet doesn't have the thing I'm looking for on it. Ah, shoot. Okay. So this question mark causes the resulting thing to match 0 or 1 repetitions. Okay. Yeah. It takes you a while to write these because they're like programs. So what this says is a minus Oh, gotta do one more thing. This is like an if statement that says a minus 0 or 1 times, followed by digits, at least one digit, as many digits as you want. That's what that says. And when I do regexes, I mean, we will email each other regexes. Like, what? Do you have a good regex for URLs? And people are like, send the regex. Because it's like a program. It takes a while to derive them. They're not like instant. Okay. So don't worry about the negative digression, the negative numbers digression. What about, so any other questions on this, right? The find all takes this pattern and sort of applies it as many times as it can to the string and pulls out the pieces that fit its template. It's like a template. Okay? Okay. So my favorite two numbers are 19 and 42. I look for one or more digits in sequence, and I pull them out, and I get 2, 19, and 42. If I ask for one or more uppercase vowels, A, E, I, O, U, in brackets with a plus after it, it says I didn't find anything. I didn't find any more than one or more sequences of uppercase vowels. And so I get back an empty list at the end of find all. Okay? So find all is going to give me a list of all the things in the string that match my template, or nothing if nothing matches. So there are two ways. There's a notion called greedy matching and non-greedy matching. And you can think of these asterisks and pluses as like loops. But you can also think of them as pushing. And so the plus and the star push out as far as they can go. And so if I am looking for a line that, or a string that starts with an F, followed by any character, that's the dot, one or more times followed by a colon. If I'm using this line that I've kind of constructed that says from colon using the colon character, the question becomes which colon is it going to look at? And if you think of this plus as pushing outward as hard as it can, it's looking for the largest possible string that can match it. And so it gives me all the way up to the second colon, right? So it's like that plus and the asterisk are pushing outwards, and they're greedy. They want as much large of a string as they can get. So you got to be careful when you use them. Okay? You can turn off this greediness of the plus and the question mark by, the plus and the asterisk, by adding a question mark. So now we have a character that modifies the previous character and another character that modifies the previous modification of that character. So we are looking for things that start with an F, followed by a sequence of any number of characters, one or more times. That's what the plus means. Question means stop when you hit the first colon. That's what that means. Stop when you hit the first colon. So this time, the only thing you get is from colon instead of going all the way to the second colon, because you've done a non-greedy match, which turns down the aggression level of the asterisk and the plus. So we can use this find all to extract things, and we'll do our little pull out the email address from, we've done this problem a bunch of times, now I'll do it again with regular expressions. And so what I'm saying here is I am looking for \s is a non-blank character, plus means at least one time, followed by an @ sign, followed by some more non-blank characters one or more times. So one or more non-blank characters, followed by an @ sign, followed by one or more non-blank characters. So you can think of it like finds the @ sign, and the pluses push outward. All right, so it finds the @ sign, and it pushes outward until it hits a space, and then like, oh, you told me you only wanted non-blank characters, and so that stops it. All right, so it finds the @ it shoves outward because of the pluses, and it finds the spaces. And so I get the extraction gives me the email address, but nothing else. So again, it's an even shorter way to pull that thing out. I don't have to split. Split's only 2 lines, split, and then I do the sub 1 item. Here I'm just pulling it out and I've got it. Now if there was more than one of these things, it would find more of them. Find all finds all the things that match in the line. Now, if I want to fine-tune my match to not just look for @ signs, but only look for @ signs on lines that start with from, which is another of our applications, and I want to both search and extract, I can use the parentheses that are not, the parentheses are not part of the match, but they tell it what you actually want to extract when you want to match more. So it still has to match the beginning of the from, followed by a space, there's a space here, followed by 1 or more non-blank characters, followed by an @ sign, followed by 1 or more non-blank characters. So the whole thing is what matches, but the parentheses around the last part here indicate what I actually want to extract. So now I have a very precise match because I'm only really matching lines that start with from space, and I'm really taking the second parameter after the space because I'm taking the non-blank stuff, the @ sign, and then the rest of the non-blank up to but not including the next blank. But I still only want the part that's the email address, and so I put parentheses around that. So there's no parentheses up here. I'm just telling find all what part of the match I actually want. So it matches for the caret from space, but it doesn't give me that back in its return data. So I can control what I extract. Any questions? Yeah. That's you can use a backslash for that. So if you really want it to be periods, you just say backslash period. Although inside square brackets, you don't need the backslash. Period is special. Period's not any character inside of brackets, square brackets. But outside of square brackets, you can match a period with backslash period. Same would be true for caret. Yeah, same would be true for caret or $sign. If you want to match a caret, you'd have to say backslash caret to make it actually mean caret, to suppress a meaning. And if you want to match a backslash, you have to say backslash backslash. So backslash is the kind of the generic escape character that means whatever's coming next, ignore its programmatic meaning and treat it like the character that it is. Okay? So again, this is just another way of doing this. With our multi-step process, we're using find and find twice and then string slicing. And it's up to you whether you decide that this is more cognitively elegant with a regular expression, or this is cognitively more elegant. They're equivalent. I think that once you understand these more succinct ways of doing things, I think you're cognitively easier to understand. But there's a lot packed up in this regular expression version of this problem. And there's a lot to learn and a lot to know. But once you know it, it's like, whoa, I know exactly what they're doing. And they didn't take 10 lines to do it. They just did it in 1 line. So this is why people once people get good at regular expressions, they love them. Because it's like, you just do stuff. And it's very succinct, very quick. So the double split version was the other way we did this, where we split the line into pieces. Then we split the email address by @sign, and we got that out. So we did that as well. So if we're going to pull out the actual host from the email address on a from line, I probably should have added something to this. Do I have a better version of this? Yeah. So if I want to put just the uctac.za out of this, I really want to use the @sign as kind of my trigger. And then, so it says, go through the string until you find an @sign. That's what that at the beginning means. It doesn't say start with an @. It means scan until you find an @. Then match that bracket caret blank means any non-blank character. So caret blank means not blank. And then any number of times is the asterisk. Bracket, caret, blank, bracket, star means any number of non-blank characters. And then I place the parentheses strategically to say, you know what, I don't want the @ sign. It was the trigger for my search, but all I want is that non-blank bit after the @ sign. So out comes the host name from the email address in just a few short characters. But again, it's just it's a little program that you're writing, and you happen to encode it in a string. They even call the act of looking at the regular expression library actually compiles it into like it's a program. So here's an even cooler version of this. And again, you can sort of refine this nicely. So what I'm saying here is I am looking for lines that start with from space followed by any number of characters followed by an @ sign. And again, think of this as greedy, so this is sort of pushing. You know, once it's past that, it's like any number of characters push. Oops, until you hit an @ sign. Great, now we're starting. Followed by any number of non-blank characters. Oops, now I hit a blank, so I've stopped there. And then the parentheses say that's what I'm looking for. So the difference between this and the previous one is the difference between this and the previous one was that now I'm searching for lines that start with from space and then extracting the host. So I'm combining with this find all the indication of whether I'm finding it or not, and if I find it, I get it. So I'm using it both to filter. So here's the DSPAM confidence, which I think was your question, was how to do the DSPAM confidence. Okay? So this is pretty simple. And all this, I hope by now, is idiomatic. So what I basically say is I want to find all the things inside this file that start with the string x-dspam-confidence : and then I've got a space here, by the way. There's a space there, colon space. Then I want to start extracting, and I want to extract any number of digits or a dot. So 0-9 dot, this is not any character, that's actually a dot. So that's numbers or digits, and I want one or more of those, and that the parenthesis tells me what I'm interested in. I don't want the whole line. I want to look at the whole line and decide if I like the whole line with all of this x-dspam confidence stuff. That's filtering the line, discarding lines, and if it finds a line that meets its happiness thing, then it says that's the piece I want. And so out comes the numbers. You got to remember that the thing that comes back from find all is a list, and even if there's only one thing in it, it's still a list. And so I basically use the len operator, say, if the list of things I got back was 0 long, if it's not 1 long, I don't like this line. Because the lines I'm looking at have that string followed by exactly one number. If I get 1, I'm happy. If I get 0, I'm not happy. And if I get 2, I have no idea what I just stumbled into. So I'm going to skip that one too. So that's what this continue is. I mean, I'm like, if it's not 1, I know how to deal with 1, but I'm not messing with anything else. And then I just take stuff sub 0, which is the first item I got back, put it float, and then away I go. And so that is a way to do the DSPAM confidence. And I think it's a good indication of sort of like the power of the regular expression of both filtering and extracting in the same expression. So again, it's a pretty succinct language. It is a pretty cryptic language until you get it. But it's also powerful, and I think in some ways very, very elegant once you get used to it. And it's like sooner or later you're probably going to run into it, so you might as well like look at it a little bit. As the question came up, what do you do for these special characters that are actually code characters? Well, if you put a backslash in front of them, then they behave as a normal old character. So a square bracket could have a backslash in front of it, or a $sign. Normally $sign means end of line, but if we were looking for $signs, like, I want to find, money amounts in all the email, If I was the federal government looking for all the email that hadn't mentioned money, I could use a regular expression to do this. This backslash dollar sign square bracket 0-9 dot plus, square bracket plus. That's a dollar sign followed by any number of digits or dots, or one or more digits or dots, and extract it, give it to me. So that allows me to extract dollar, things that have dollar signs in it, because dollar sign normally means end of line to a regular expression. So, should fix that. So, any questions? I get the sense that 1 in 3 of you are going to use these on the next assignment, and 2 and 3 are not going to use these on the next assignment. Some of you are like, why did you teach me that other stuff? Because this is so cool. And the others are like, whoa, you just confused the heck out of me. I was just getting that other stuff. So that's okay. That's, if you don't like it, you don't need to use it. If you do like it, it really makes your program shorter, and you're going to find, it'll come back to you. There's other places that use regular expressions. So, any questions? Okay, so, yeah. Yeah.
Is there any way to get people additional description and say, I want to get the number, I want to get
Well, you could do 4-digit numbers. You could do 4-digit numbers by something like this. And I do this all the time. So if you wanted only 4-digit numbers, what you would do is you would say 0-9, 0-9, that's a 2-digit number, and that's a 3-digit number. So that's a 3-digit number, right? That says, if you did that, that says 3, because each of those brackets is 1 character, right? And so that's a 3-digit number. And I could have like I could say I'd like a digit followed by a dot followed by a digit. Find me those things. Or I would like one or more digits followed by a dot followed by 2 digits. So that would match like 1, 2, 3, 100.05. Match those. So I'm getting 2 digits after the decimal place. So I'm finding floating point numbers that have 2 digits after the decimal place. So, but if you want things like 2 digits, you just kind of repeat that. Now that one I didn't have to look up. That one I knew how to solve. So some regular expressions I do know how to do. It's the tricky ones that I don't know how to do. Any other questions? Okay, so one last thing. Somebody came up during the break and asked about the new book and the midterm. I want to make absolutely clear that the new book has nothing to do with chapters 1 through 11. I mean, the new book, chapters 1 through 11 have not changed a single word. The only thing in the book that's changed is chapters 12, 13, and 14. Well, no, 13, 14, and 15. So you don't worry about the new book. The only reason I have the new book out there is in case somebody wants to volunteer and find typos for the later stuff. But ignore it with respect to these first 10 chapters. Okay, so the new book, it's not better, it's not worse, it's exactly the same up through and including chapter 12. It's awesome in 13, 14, and 15, but it's not changed in any way. It's got a different copyright in it, but other than that, it doesn't. So don't look at the book. Don't feel like the book is something you have to look at unless you want to look at it. Okay. So our next lecture is a history lecture, which is a departure. There will be no double quotes, no single quotes. There will be just like dates and people and places. Whatever brain we've been using, we're switching back to the other one for the next couple of weeks. And I do this on purpose, I told you before, to give you sort of a week to sort of breathe. Right? I don't want to like, we've been sprinting, and you've been sprinting, and I know you've been sprinting, right? And you've been sticking with me, and you've been, keeping up with my pace, and I thank you for that. But I do know that you need to take a rest. And I don't want to do the midterm too quickly, because I think that you need to reflect on it and let your own mind catch up with the things that you've like, and then you realize you did learn something. And so I don't want to put you in. So again, what we find is you'll spend time with your GSIs. I'll give you sample stuff. Finish the chapter 10 stuff before you start working on the midterm, and then do practice midterm stuff. And we have plenty of time, because we have all this week and the beginning, we have all next week and the first part of the following week for you to kind of like get yourself ready for the final. Okay? And the final will look the midterm will look a lot like everything else you've done. It is not a departure. And like I told you, 10% of the people are pissed because it's too easy. They're like, and then I give them a hard one. And if there's 10% like, oh, that only took me 20 minutes. I'm like, okay, congratulations. That's actually a good thing. That's not a bad thing. So some of you will ace it. And there's partial credit. And there's the makeup if you don't do well on it. Like if you just totally don't get it, we just sort of coast on forward with a multiple choice test. There's more Python in the rest of the class, but I will give you 98% of the Python for the rest of the class. We're going to do more fun things, write less code. You will write less code. I will give you more. You will run it, maybe look at it, but you're not going to be writing anything from scratch after the midterm. There'll be no writing from scratch. There'll be maybe reading stuff I give you. Okay? Okay, see you in a week.